Hello, my name is Luay Hamami. I'm a student in ECE 495, Integrated Systems 1. I'm a member of Group 3 along with Julius Ali Pala, Imran Hakimji, our group leader Antonio Pena, and Scott Rathwag. We demonstrated our robot back on Friday, October 22nd. At that point, we had the bulk of the mechanical structure in place. We were able to fire a ping pong ball into a specified cup with a fair amount of reliability. Um, However, we were manually feeding the robot. We didn't have the trigger in place, and we were powering the robot with a DC power supply and an amplifier in the laboratory. To that point, we'd spent $155 in mechanical and costs to cover the mechanical structure. Again, that represents the bulk of the mechanical costs. The trigger, the only thing left that we need to add. In addition, we need to build the power supply and the amplifiers. 4 amplifiers will be needed. One for the spinning wheels mechanism that actually fires the ball, one for the trigger that releases one ball at a time, and one for each of the DC servos that angularly position the firing barrel of our robot. We also need to compose and implement our image processing software, and we need to compose and implement a decision algorithm so that our robot can use image processing software to decide which cup it needs to fire a ball into. And all this needs to come together in MATLAB Simulink. We have broken down those tasks into individual tasks. Our group leader Antonio is building the power supply and the amplifiers. Again, 4 amplifiers will need to be constructed. Julius is handling the image processing. I'm composing the decision algorithm, and Scott and Imran are figuring out how everything is going to run in MATLAB and Simulink. That includes the C code that's being composed for the image processing and the decision algorithm being converted into a form that can be used in MATLAB and Simulink, or rather executed. And also the junctions between, say, the output of the decision algorithm program saying go fire in this cup, and the actual numbers that would be needed, i.e. the 2 angular positions and the speed of rotation of the spinning wheels launching mechanism to correspond to launching to that cup. So far, everybody seems to be making good progress. The power supply and amplifiers are about completed. The image processing is about completed as well. The decision algorithm, I have composed a strategy for the game. I still need to actually write the C code to implement that strategy, but it's laid out in detail, and I suspect that that will go rather smoothly. And Scott and Imran are good ways towards investigating how everything's going to come together in MATLAB and Simulink. Once all of these components are completed, we of course need to come back and add the trigger. We're going to use the DC servo that we used in Project 2 in order to facilitate that. That will require cutting another window in the PVC pipe that is the barrel for launching the ping pong ball, and putting a gear on it that will essentially just release one ball at a time. So once we have our individual components together, again, that includes the power supply and amplifiers, the image processing software, and the decision algorithm, and then how all of that comes together in MATLAB and Simulink will come together, add the trigger, and then sit down together and get everything working all in harmony, we hope. And then we have penciled in 3 time slots for next week so that we can go and test the robot against various game scenarios. We can set up the robot on one side of the table and then replicate a game-like situation in which we hand drop balls on the opposing side and see how well our robot can recognize the game state and how well it chooses where to go and with how much success it's able to launch its own balls into the cups that are needed to either block the opponent from winning or to recognize that it can win and firing a ball into the cup that leaves it with a winning 3-in-a-row combination. We suspect that after that testing, some minor tweaking will need to be done to the calibration perhaps, but also to the image processing software and to the decision algorithm. So that's where we stand. We're optimistic that we can have all of our individual components completed by Sunday, bring it all together by early next week, and be ready for our time slots on Tuesday and Wednesday to go in and do our testing. Thank you for your attention.